Hello everyone, this is MHM Mubashir again. Hope you are doing well. So after a long break, I'm here again for the bioinformatics tutorial BTC509. And within this tutorial, I'll be talking about how we can predict a 3D structure of a protein by using the tool SwissModel. We already know that how to retrieve a FASTA sequence from NCBI or from UniProt. Now, I'll be searching a FASTA sequence for a specific protein, and then after getting the FASTA sequence, I will paste it to the server which is known as SwissModel, and then we will try to see if that server could generate the model or not, or that server could predict the 3D structure of that particular protein accurately or not. So to go to the SwissModel, just Google SwissModel and then press enter. So this is the server we are looking for. So we have to click start modeling. And whenever I have clicked start modeling, we have to paste the FASTA sequence of our protein. And to get the FASTA sequence, you already know that we have to type NCBI, and then from NCBI I will be trying to model the protein XA21. To do so, we'll be typing XA21 here, and we'll be search for the amino acid sequence of this particular protein. So I have to click here in the protein, and then let's click the FASTA here. So this is the sequence of ours, and we just need to copy and paste it here. So we can give a name for this, like say for an example, for this one I am typing XA21, and you can put your email address here if you want to, but I'm not advising you to do so because it will automatically generate the result within this server, so you don't need to put your email address there. And this is the sequence we have given to the server, and then we can do two things. One is search for templates and another one is build model. So we can either click here or we can click here. So if you have a very specific template that you want to use for modeling this protein, you will go for this one, search for templates. And if you want this server to search for the template as well as to model the proteins based on its algorithm, then we have to click build model. So for now I am clicking build model. It will take some time because our protein sequence is a bit lengthy, like 1025 amino acid, and the longer the sequence is, the longer the time it will take. Let's wait for a few minutes. Maybe it will take 15 to 20 minutes. So I'm waiting for that period of time. So let's wait and let's see how many templates it could generate, at the same time how many models it could generate. So let's wait. Okay. So finally we have got our results in our hand. So this SwissModel generated 50 templates for this particular sequence. Basically, if you have a lot of templates for this particular protein or amino acid sequence, it will generate up to 50 templates. But sometimes it may happen that the template number could be like 10 or 5 or 4 based on the availability of the protein structures in PDB for these which are aligned with this particular sequence. So as we have more than 50 templates, so it is showing 50 for now, and it has modeled 4 structures, or it has predicted 4 structures that we can see here. Let's say model 1, 2, 3 and 4. One thing in the template, you have noticed that it took the templates based on its algorithm. Like it took the first one, and then this one it took like 4MN8, and then it took this one and it took this one. So it took these 4 templates for modeling those 4 predictions. So let's look into the model. Like I was saying to you that you can do it manually. Like say for an example, if you want to model this protein with a particular template, say for an example you want to model this protein with the structure 4MNA, then like you have to click here and you have to click build model, and that's how we can use very specific template for predicting our 3D structure. Okay, so whenever I'm clicking on any template and if I click build model here, so it will generate the structure, or it will predict the 3D structure of our protein XA21 based on the templates of 4MNA or like T-cell structure of FLS2. So let's talk about the result that we can see it from here. So first thing is, like you can see that you can have the structure, 3D structure here. So this is the 3D structure that predicted SwissModel for our protein XA21. So if you click here, it will show you the entire structure by rotating, but you can see it in a big screen. Like if you click here, it will pop up a new window and then you can see the result here, even if you can click it here. So it is basically showing the cartoon structure of this protein, and you should always look into the cartoon structure of a particular protein, because whenever you want to publish a structure, that must be the cartoon structure. Okay, there are some other structures that you can also see, like say for an example, if you want to look this as tube, it will generate the structure like this. If you want to look these structures as ball and stick, you can look into the amino acids here as ball and stick, and this is important whenever I'll be talking about the docking part, and whenever I'll be looking for the interactions, okay, with the other associated proteins. So, and then we have definitely trace, like very tiny little thread you can see here, and also you can have some surface structure like this one and space fill like this one. So you can try many different types for seeing the model of this protein. So I'm setting it as cartoon structure. Okay, so I'm closing it here. So here is the structure of ours. Also you can see different other properties of this structure, like if you click here, then you can see the polar amino acids of this protein. Like you see, only the polar amino acids are visible here. Say for an example, you want to see the aliphatic amino acids, so it will generate the structure like this. If you want to see as it no color, so it won't generate any color, and definitely you can change the background like from black to white. And if you want to see the hydrophobic amino acids, then it will generate the structure like this. And if you want to see the proline amino acid, then it will generate the structure like this. Also, if you want to generate a very nice model, like you want to give it a rainbow color, then it will generate a structure like this. But for us, the default parameter is Qmin. What is Qmin? I'll be saying to you. So I'm clicking it here. So these are based on the quality of the amino acids. So I'm keeping it like that and just click it here. So if you want to see a very specific amino acid, say for an example, you want to see the amino acid, this one, then it will zoom into that particular amino acid. Okay. But if you want to see a part of the sequence, like you want to see this area, then it will generate the structure like this. Whenever you are seeing an arrow like this, that means it is generating the beta sheet. And we can definitely see the alpha helix as well. So to go to the default position or default orientation, just click here. So automatically it will zoom out and will take you to the default condition. Now let's talk about the quality of the model. So two things here we can see from the SwissModel. One is GMQE, which is Global Model Quality Estimate, and then we have Qmin. So for SwissModel, we have only these two parameters, but we'll be validating these particular structures with some other servers, like we will be seeing these structures quality in EROD, Verified 3D, Ramachandran plot, and so on. For GMQE, the value is 0.31. The GMQE value could be like from 0 to 1. The closer to the 1, the good the structure it is. Okay, and the Qmin value is minus 3.20. That is, it is showing thumbs up. That means the structure is good. If it is below minus 4, then it will be showing thumbs down. That means the structure is not good. So this is showing minus 3.20, but the value of GMQE is very less, like 0.31 is not close to the 1. So that's why the structure is not good normally. And if you click here, then you can see that our predicted structure is here in this area. Like you see, the model structure is here. Usually, the protein quality is considered good if that stays within the middle area. Even if it stays within this area, it is also considered as good. But if it stays like above this or below this, then the structure is not good. Okay, so ours is below that. That means our structure is not that much good. Why it is not good, I'll be showing it to you soon. So I'm closing it. So this is the structure we have got, and let's see, they have done a multiple sequence alignment for this protein, and you can see that this is part of our sequence of XA21, but this SwissModel couldn't generate the structure for this particular area. Not only that, for this particular area it couldn't generate any structure as well. That means it modeled only partial of the XA21, not the entire XA21 protein. So that's one limitation of this particular server, and that's one limitation for the single template modeling method. I'll be talking about multiple template modeling methods in the future lectures, but let's talk about single template modeling. Like we have used only one template or only single template, like which is 5gij.1.a for this case, and this is the coverage that it had with the XA21 sequence, and you can see it from this area as well. Like you can see that it could only model, even it generated 4 models, right? This one, this one, this one, and this one, and none of the models could predicted the entire structure of the XA21. That means it couldn't model the N-terminal region, and it couldn't model the transmembrane region or the kinase part of this protein as well. So the sequence identity is here. So the GMQV value is for this one is 0.28. This is the model number 3. GMQV value for this one is 0.28 as well, 0.27 as well, and for this case is 0.31. So this is the best structure we can get from the SwissModel. But yes, like I said to you, that this structure is not good enough for us. This is the basic of the SwissModel server. So if you have any question, you can ask me in Facebook group, or like you can email me. So this tutorial of SwissModel is up to now. In the next tutorials, I'll be showing you how you can validate the model. So till then, have a good day. Thank you everyone.